is getting hotter. The past 3 years were progressively the hottest years on Earth. Worldwide 2016 was the hottest ever. According to NASA, the average global temperature for 2016 was 0.99 degrees Celsius hotter than the 20th century average, and it's only getting hotter. January 2017 was the hottest ever in Australia, and it's heating up and drying out as the country experiences more extreme and prolonged heat events. It is shown that the average rainfall between May and July has decreased by about 19% since 1970 in the southwest of the country. A report also shows that 15 of the 16 hottest years on record happened in the past 15 years. So with hot days 5 times as likely to occur today as ever before, southeastern states are in particular vulnerable to a significant increase in fire weather across most of the fire-prone regions, Dr. Bruganza says. With all these facts confirming global warming and climate change is getting the better of us, I think clothing color will make a significant change, as the small steps lead to big changes. We can start with a small step like making sure we're wearing the right color during the right season. The results to my experiment can be used for people who wear hijab, but also other clothing accessories. The results can be used for other things such as what color your roof should be when building a house. So how is my experiment different? My experiment is different because I'm doing it in a closed room rather than outside to make it more accurate. Many people have done this experiment have not really thought about the control variables. They did it outside in the sunlight. The sun intensity could have changed throughout their experiment, therefore affecting the results. I'm going to be doing my experiment in a closed room using a stage light for heat, which will have the same intensity throughout, giving me accurate results. Although no one has ever done an experiment like this using cotton hijab caps, most experiments are done using construction paper and water, which are not that accurate because water actually needs a lot of heat to warm up. So for the method of my experiment, I'm going to start off by putting one hijab cap on each of the mannequin heads. I will be using the colors black, white, and another primary color. Then I will place the mannequin heads on a flat surface such as a table in a closed room. I will make sure that no one enters the room for as long as my experiment is being conducted. After that, I will place the stage light in a suitable position in the room. The light will provide heat for my experiment. I will then get a data logger and set the times I need for my experiment. I want the data logger to measure the temperature under the caps for every 10 minutes for an hour, starting from the initial temperature at 0 minutes. After setting this onto the data logger, I will take the probes and set them under the caps, taping it securely so it doesn't move out of place. I will then leave the room for an hour while the experiment is being conducted. After an hour, I will go in and check the results on the data logger. I will make 3 graphs, one for each color, and make a line of best fit for each of them. After that, I will turn the stage light off and move the mannequin heads to another room. I will set the data logger and probes once again to measure the temperature under the caps every 10 minutes for an hour. After that, I will add those results of the same graphs as an extension so that I can make a curve of best fit and compare it to other colors. I'm doing this because I want to know how long after the heat is taken away does the heat remain under the cap? How long does it take for the heat to get back to its initial temperature? Is it different for each color or not? And is there one particular color that traps heat longer than others? 2 to 3 days later, I'll repeat the experiment in the same room again, collect the results, and make 3 more graphs with a line of best fit for each of them. For reliability, I'll repeat the experiment 3 times altogether. I will then find an average from the 3 trials and make 3 final graphs and come up with a conclusion. To make sure that my experiment is reliable, valid, and accurate, for reliability, I'm going to be repeating the experiment 2 to 3 times under the same circumstances and compare the results to make sure they're consistent and close and there are no outliers. I'll find the average and make a graph to see the trend. This would be easy for me since I'm doing it in a closed room rather than outside, so the sun intensity, the wind, and other stuff won't affect my experiment. Validity. I will follow the same procedure under the same circumstances, and I'll make sure that it is a fair test by only changing one independent variable, which is the color of the undercap, and keeping all variables constant. I'm going to have control variables such as the amount of heat, type of fabric, how tight the cap is, the size of the mannequin, and other things. For accuracy, I'm going to be using a stage light to provide heat for my investigation rather than leaving it out in the sun. This can help make sure many factors are controlled, such as light and heat intensity. The sun will not be hitting either part of the mannequin head directly. There will also be no wind interference that will disturb me every time I repeat my experiment, as I will be conducting the experiment in a closed room with no wind. I don't have to worry about light intensity, wind speed, or moisture in the air on any given day. I'm also using a data logger that will precisely measure the temperature under the caps every few minutes for a given time. This is more accurate than me using a thermometer to measure the temperature myself. So I have a few questions to ask. So why does black absorb more heat than white?
Wait, oh no, never mind.
Because it absorbs all the heat and it doesn't reflect any light
Yeah,
back.
that's kind of correct.
Where'd you get the candy from?
The correct answer is, yours was correct, but because a black object absorbs all wavelengths of light and reflects none, whereas white objects reflect all light and absorb none. The next question. What color light does a green apple reflect?
Green.
Yeah. Okay, green light, because it absorbs all other colors and reflects green, which is why we see it as a green
Give her a candy.
What
Mariam.
is happening to the earth over the years?
Death.
Anyone else?
The
Hazard?
days have become more hot.
Yeah.
And also the days are also becoming longer.
That's the correct answer. Okay, does anyone have any questions?
I think.
Can you stop? It's getting old.
I'm
No, it's not very.
Yes, it is.
Your grandpa's
So,
getting
I think that this is like I'm really interested in this color reflection and stuff, but I had something to say and I forgot.
Thanks to you, Marianne.
Oh,
I
don't do
made me
anything.
forget what I wanted to
Why do you guys
say.
always have to blame me for everything?
Okay, Hazard?
I think it's very well planned.
Don't worry, I won't do it for
Thank
you.
you. Anyone else?
Mariam. Okay, for the first 20 seconds, it kind of didn't record. So, and then I realized
Sorry, I'm looking at
it's like 6 minutes. No, it's
You know how you said you wouldn't let anyone into the room?
you. Yeah.
Like, but how about you entering the room?
I'm going to enter it at the beginning while setting the times and everything, and then I'm going to leave the room, and the data logger is going to record all the measurements and everything, the temperatures, and then I'm going to enter the room after an hour when it's done.
So you're only going to do the experiment for an hour and then check the results?
Yeah, and for an hour every 10 minutes, so there's going to be 6 measurements for each color on the data logger, and then I'm going to repeat the experiment a few more times for an hour.
Wait,
Yeah.
you know how you said every 10 minutes you're going to have a different color? How are you going to change the color?
Not a different color, so I'm going to have like
Yeah.
3 different mannequin heads, and I'm going to have different color caps on each of them, and then it's going to measure the temperature. Yeah.
How close do you intend to put the stage light away from the mannequin?
I don't think that really matters because it's going to heat up the
No.
same, but
oh my
I'm
god.
going to keep it like, if it's on the table, I'm probably going to keep it towards the back of the same distance, a few meters away.
Do you know why other tests was actually done under the sunlight?
Because the heat,
It's natural
there's
heat.
heat directly given to us.
Or in other words, that's a practical use of your clothing, isn't it? You expect to be outside, right? Yeah. And the whole point about using a stage light is because the artificial light will have a constant intensity. So therefore, when you measure something, you actually have measuring. How can you have a fair test?
Yeah.
But then again, the next thing that you have to ask is, well, how bright does bright has to be? So my suggestion maybe is this: take the lux meter again, yeah, and then go out there at right in midday when the sun is the strongest.
Yeah.
Record that number. Next, when you go back into the dark room, move your stage light until you actually at the distances that give you the exact same number or very close number out compared to what you actually got outside. Does that make sense now? That would actually simulate the intensity of light that you try to achieve. Does that make sense now?
Yeah.
Yeah? Okay.
Does anyone have any other questions?
That was
All right.